In today's lab, we're going to be working with these devices, and you have 3 of them in your kit. They're called capacitors. You actually have 6 of them, but 3 different sizes. And we'll be using all 3, and actually, in some cases, we'll use a couple of them for the activities that we're going to engage in. First of all, what is a capacitor? We're going to be talking about it in class, although we haven't quite gotten to there yet, but we're close. A capacitor is a device that stores a charge. And to exhibit it, I want to show you, and I'm going to ask you to do this on your own too. Take your meter, set it to the voltage setting, the setting that says 20 volts. Put the negative side of the meter, the black side. I'm going to use my alligator clips that you don't have. You'll just have to touch them onto the wires, but I'll use this so I can more easily show you the video. But put it on your meter like that, and your meter should show 0 volts because your capacitor right now doesn't have any voltage across it. But I'm going to change that, and I'm going to change that by touching the capacitor to a battery. And I'll start with a 9-volt battery. And the way I want to do this, the negative side of the positive side is the side that is circular, and the negative side is the side that is like a hexagon on it. And the negative side of the capacitor, these types of capacitors have a negative and a positive side too to make them work the way we want them to work. The negative side has some negatives written on it. You might be able to see it from there. But look at your capacitor and see. Just pick one of your 3 capacitors. You'll be doing it with all 3 of them. And set it on your battery such that the positive side is touching the positive terminal and the negative side is touching the negative terminal. Leave it on there for just a few seconds. That was long enough. And then what I'm going to do is I'm going to hook it up to my meter, and we're going to see if the meter shows anything. So I'm going to pick up my meter here, and hopefully you will see something. Remember, I hooked it up to a 9-volt battery. Let's see what my meter says when I hook it up to the capacitor right here. Looks like it's saying 9 volts, 9 plus volts. Of course, it's dropping. I'm going to tell you what's going on. I could have left my capacitor like this after it touched the battery. I'll touch it again the right way so that the plus side is touching the right terminal and the negative side is touching the proper terminal also. This capacitor now has 9 volts across it. You saw it because we measured it. I could set this capacitor on my shelf in theory and come back to it, in a couple weeks. It'll still have 9 volts across it. What happened? Well, on the capacitor, we'll talk about it in class, there's actually 2 plates. And on those plates, charge flows when it touches the battery until no more charge can fit on the plate because charge doesn't like to be near other charge that it's like. But there's another plate on the opposite side of this capacitor, and they're not touching electrically. They're 2 isolated plates. And you get negative charges on one side, positive charges on the other. And if you remember from class, when you have negatives on one place and positives on the other, you have a difference in potential between them. That difference in potential is a voltage, and that's what we're measuring with the meter. So isn't that cool? This should still show me 9 volts. I'm going to hook it back up. I've been sitting here for a few seconds or maybe a minute talking to you. And let's see if the capacitor still has about 9 volts across it. Shouldn't change much until I put the meter across it. So I'm going to do that. Yep, it was 9 volts. It's dropping now. But that 9 volts was sitting on that capacitor right there. And you can see it's dropping. So the question then is, why is it dropping? And the reason is because the meter itself, it takes charge flowing through the wires of the meter in order for it to measure whatever it's measuring, whether it's a voltage or current or even a resistance. It actually has to have current flowing through it. Well, the current that's flowing through it is coming from the capacitor. So the charge that's on the plates of the capacitor is actually leaving the plates of the capacitor and going to the other plate. And while it's doing that, it's passing through these wires of the meter and registering the voltage on the meter. But as that charge flows, the voltage the charge on the capacitor is dropping. Therefore, the voltage on the capacitor is dropping. And that's what you're seeing the meter telling us. So the meter itself is kind of a parasite in a sense. Its measurement doesn't come for free. It takes some of the charge that is creating the voltage to make the measurement that it's showing. And in so doing, the amount of charge on the capacitor plates goes down, and so does the voltage. Let me show you something else. First of all, what I'm going to do is I'm going to touch these 2 together. And what I just did in touching those two together, and you can try this on your own, is I made it so that the charge is now, there's no charge on the plates of the capacitor. It all equaled itself out. So if I put it on the meter now, the meter would now show 0 volts. Now I'm going to put it on a 6-volt battery. So my 6-volt battery is right here. Again, I'm going to put the negative side on the black wire of the battery, and the positive side on the negative side is always the shorter one on these capacitors, because there's 2 lengths of wire on these capacitors for each lead. All right, I put it on for a couple seconds. This should now be charged up. Let's see if it indeed is charged up to the value I think it should be charged up to, which would be 6 volts. So I'm going to show you the meter in just a second. Hook this on here. Here's my meter. I'll just hold it. And I'm going to hook this lead up here. I hope it shows 6 volts or something like 6 volts. Yep, it must have been. It's dropping. So the capacitor is going to have whatever voltage the battery has when it's hooked up to the battery. So you hook up the battery to the capacitor. The capacitor is the only element in the circuit, so it has to have the same voltage across it that the battery does. So the battery, effectively, we call it, we say it charges up the capacitor. So capacitors themselves are a type of storage. They're actually storing charge or even storing energy. There's energy stored in this thing. Not a lot of it, but some. So I'm going to ask you to repeat this with each of the capacitors. They should all show you the same thing. The bigger one should show 9 volts when you hook it up to the 9-volt battery, and about 6 volts when you hook it up to the 6-volt battery. The middle-sized one should show 9 volts when you hook it up to the 9-volt battery, and 6 volts when you hook it up to the 6-volt battery at first. Of course, it'll drop down just like the other one did. And then the smaller one, which is I think the one I showed you with, should show 9 volts with the big battery and 6 volts with the smaller battery. So then the question you're probably asking is, if they all show the same voltage, then what's the difference between a larger capacitor, a middle-sized capacitor, and a smaller capacitor? And by the way, the values are on the capacitor. The smaller one is 10 microfarads. You'll see a mu and then an F. That means microfarad. The middle-sized one, I believe, is 100 microfarads. I need my glasses to read it. But this one should be 100 microfarads, I believe. Yes. And then the large one here is 1,000 microfarads. It's actually a millifarad. So these are a factor of 10 larger than the next one, small, medium, and large. And what's the difference then? If they all show the same voltage, what's the difference? And that's what we're going to talk about both in class and in the rest of this lab. You're going to be making some measurements in lab where this difference will come out. Turns out that the one that's larger value, can hold more charge. Has the same voltage, but it holds more charge. So it means it has a bigger oomph. It can sustain that voltage a tiny bit longer than the middle one or the smaller one. So you'll see that. We're going to be using our circuit boards, some wires, and a resistor in this lab as we make other measurements with our capacitors in the remaining part of this lab. Okay.